So now that we understood adjacent angles, let's try to understand some of the other concepts. So let's start with the adjacent angles itself. So what did we understand? Angles sharing common arm. So if I draw that was A, B, C, OA. In this scenario, OB is my common arm. Angle AOB and angle BOC were adjacent angles. The reason is OB is a common arm shared by these two angles. But can I call this as a linear pair? In the sense, angle AOB and BOC, can I call this as a linear pair? There is a condition for linear pair. There is a common arm, but the non-common arms, which are non-common arms here, OA and OC are non-common arms. So condition is non-common arms are opposite to each other. If I actually hold a mirror just on this vertex against OC, so I should be able to see a line going that side, which is that side. So that is opposite to OC. So now do I see anything opposite here, opposite to OC? No, I don't see anything. Opposite to OA, I don't see anything. So let me draw that one more time. So if I take OC and there is a common arm, can be anywhere, and anything opposite to OC, let's take an opposite ray to OC, which is OA. So OA is opposite to OC. Then we call these two angles form a linear pair. They form a linear pair. Angle AOB and angle BOC form a linear pair. They should be opposite. Doesn't have to be that. So let me draw this figure little bit different. Let's take OC. Let's take that OB. If I extend this OA, so what I did is, now in this scenario, which is the common arm, so OC is common for this angle and this angle. So OC is common here. OC is common arm, and OA is opposite to OB, or OB is opposite to OA. So what happens? Angle BOC and angle AOC make or form a linear pair. So based on that, the condition goes something like that. So because, let's just draw that here so you will know exactly what I'm talking about. A, C and somewhere B. So if OA is opposite to OC, or OC is opposite to OA, it's actually going to make a straight line. So if you know the different types of lines, a straight line actually makes an angle of 180 degrees. So coming back to that, bringing that concept as a straight line making 180 degrees, if these two are adjacent angles and non-common rays are opposite to each other, then the sum of these two angles is going to be 180. So what does that mean? We come to conclusion that linear pair of angles is actually going to make 180 degrees. So remember that, it's very important. So sum of linear pair of angles is actually equals to 180 degrees. So now angles at a point. This is a point. How many angles I can have at a point? Any number. So first let's try to understand how many rays I can draw from a point. As we already discussed, infinite number of rays. So infinite number of rays. So how many angles I can make at a point? Any number of angles, many angles. But the condition with this is, if I start from here, if I start from any rays and coming back to that, if I start from here and then go one circle, in the sense I count that angle, 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 and add all of them, the angle at that point is actually going to give me 360 degrees. Nothing a straight line. If it is straight line, you already know it's going to be 180, and rest of it, actually if I sum all of that at a point, is actually going to give me 360 degrees. So remember that angle at a point, sum of angles at a point starting from anywhere going back to where I started is actually going to give me 360 degrees. Then let's continue with the complementary angles. So what is a complementary angle? Sum of measures of two angles is 90. So let's take two angles, that is 1A, B, OA, if that is 60, and another one is this is C and this is D, and this is 30. Sum of these two angles, which is 60 plus 30, is 90. So sum of the measures of two angles equals to 90 is called as, those two angles are called as complementary angles. So now if I am actually going to write that in a sentence, angle AOB is complement to angle COD, or COD is complement to angle AOB. In the sense, if I am saying this is complement to that, or that is complement to this, in the sense if I add these two angles, I am actually going to get 90 degrees. So that's what you need to remember. Similarly, for supplementary, if these two angles, angle, sum of these two, if it is equals to 180, it's called supplementary. So in that scenario, angle, whatever angle is supplement to this, or this is supplement to that. So note here what I've done is I've drawn two different figures, but still I'm calling it as, if sum of those two is 90, they are supplement to each other, but they don't have to be adjacent angles. So remember that they can be, they don't have to be. So if I'm actually going to make this is 30, this is 60, these two can be adjacent, but still they are complementary. There is no condition that they don't have to be adjacent to each other, but they can also be separate. But the sum of these two is 90, it's going to be complementary, or if sum of these two is equal to 180, it's going to be supplementary. They can be adjacent or they can be separate. So that's a condition you need to remember in this.